One, welcome back. All right, happy Friday. Here we go. We're on page 167, reviewing the multiples of 5. Multiples of 10 are homework due on Monday. First homework check for next week. Make sure you've finished all your homework checkies for this week. Check the portal for due dates and assignments, and also here for due dates and assignments. Okay, on Google Classroom. All right, so let's get started. Whoops. Okay, on page 167, number 5, we're asked to find dy dx if x equals tan y. Okay, now if you could actually solve this explicitly as y is a function of x by taking the arctan of both sides, but you don't know the derivative of the arctan, do you? So that's basically what we're going to get here. So dy dx would be the derivative of y. If you solve for y here, y is the arctan of x. So we're really finding the derivative of the arctan. How do you do that? Well, chain rule. Differentiate both sides implicitly with respect to x. Derivative of x with respect to x is 1. Derivative of tan of stuff is secant squared of stuff times the derivative of the stuff. See, that's chain rule because it's an inner function y, which maybe we don't even know what it is. All right, so get dy dx alone by dividing both sides by secant squared. Okay, so dy dx is 1 over secant squared of y. Now, secant is 1 over cosine, so you could say that's cosine squared of y. But here's another way to look at it. Let's see, can I draw triangles on this thing? No, just rectangles, circles, and lines. Okay, so let's make a right triangle like this. Look. Consider this right triangle. Pretend that's a right angle over here. Okay, so let's pretend that this is a right angle here. Oops, nope. Well, what is wrong with that? Why can't I do a right angle symbol? All right, let's say that's good enough. Okay, so if we're talking about y, whoa, I need a pen. What am I doing? Oh, that's why I was drawing weird. I need a pen. Okay, so in other words, if you take the arctan of both sides, y is the arctan of x. I wrote it backwards. The arctan of x is y. So x is the... so when you do arctan, remember what arctan does. You plug in a tangent value and you get out an angle. So let's say y is the angle. Let's say it's here. What we're saying is that the x is the tangent. So how do you get tangent? Sohcahtoa, opposite over adjacent. So let's say x over 1 would be opposite over adjacent equals x, right? Isn't it saying tangent of y is x, right? Okay, so how do you get the secant? Well, the secant, again, like we said, is cosine, is 1 over cosine, isn't it? So let's figure out the cosine of y. What's the cosine of y? Well, that's going to be the adjacent, Sohcahtoa, adjacent over hypotenuse. What's the hypotenuse? A squared, added, squared, 1 plus x squared square rooted, according to Pythagoras, is the hypotenuse, right? So what's the cosine? 1 over that. Goody. Alrighty, 1 over that. So what's 1 over that? Secant. So what is the secant? The secant is the reciprocal of that. Ta-da! And I want the secant squared. So dy dx is 1 over the square root of 1 plus x squared if y equals arctan of x. You just found a new derivative. Yay! Amazing. All right. So if y equals the arctan of x, the derivative is 1 over 1 plus rad 1 plus x squared. And no, sorry, I have to square that, right? I have to square this. Whoopsie, wrong, bad. I want secant is the square root of 1 plus x squared. I want secant squared. So square that, get rid of the radical, in other words. You're going to get 1 plus x squared. So the derivative of arctan is 1 over 1 plus x squared. Okay, nice. All right, number 15, right? You're doing 10, 20, 30 for homework. I'm doing 5, 15, 25, like that. All right, same page, 167, number 15 says, if x cubed plus y cubed is xy, do I have page 167 in here? Where's my 167? There it is. I'm just sorry, I don't have a copy of the questions in front of me. There you go. All right, so number 5, right? So number 15, and find where the slope of the curve is defined. In other words, find the derivative, find the slope of any tangent line along this curve. And this is some kind of weirdo curve. We don't even know what it looks like. This is really hard to graph something like this. You could use derivatives to figure this out, but we're not doing that right now. All right, so let's differentiate x cubed with respect to x. That's just 3x squared, power rule, right? But then y cubed, you're going to think of it as chain rule, is stuff cubed. So you're going to say plus 3 times the stuff squared times the derivative of the stuff inside. So the inner function is y. So it's y to the third, right? It's like we're plugging y into x cubed. Equals. Now we've got to do a product rule here. So u and v together, u v prime plus v u prime is the product rule. So the first guy times the derivative of the second guy plus the second guy times the derivative of the first. Derivative of x with respect to x is 1. Okay, so what you got to do is get dy dx alone. So how about if we, let's think about this. Subtract this from both sides. Get all the dy dx's on one side. Subtract this from both sides, right? And get everything else on the other side. So let's do that. I'm going to get 3, this is pressure sensitive, this S-pen, huh? 3y squared dy dx. Some people might write y prime here. That's technically wrong. Minus x times dy dx equals y times 1 is y minus 3x squared. Okay, let's factor out the dy dx, and then we can get it alone. You get 3y squared minus x, do you not? Equals y minus 3x squared. And so dy dx is going to be y minus 3x squared divided by 3y squared minus x. There's a y here. Okay. And that's it. So very often when you start off with an implicitly defined relation, I don't even know if this is a function, you end up with an implicitly defined derivative when you differentiate it. In other words, it's not dy dx is not just in terms of x. When we're finished, and we started off, we didn't have y alone as a function of x, right? That's called implicitly defined function, or it may not even be a function. I don't know what curve this is, what shape this is. Alrighty. So next, let's take a look at 25. All right, 25 says, find the tangent and the normal to the curve at a given point. In 25, we're doing y equals 2 sine of pi x minus 1 at the point 1, 0. Or the tangent line is easy. It's y minus y1 equals m times x minus x1, where m is the derivative of that point. And we've already got x1, y1, it's 1 and 0, right? So we just got to get the derivative there. And then the tangent, the normal is perpendicular to the point of tangency. So it's the exact same equation as the tangent line, except for the slopes are negative reciprocals of each other. So let's do that. 25, page 167, number 25. All right, so if y is 2 times the sine of pi x minus y, what's the derivative? Well, dy dx, the derivative of y is dy dx, equals, now don't forget, 2 times sine is 2 times a function. The derivative of a constant times a function is a constant times the derivative of the function. Okay, so forget that. Forget about the product rule, in other words. You can do it, but it's more work. You're going to get the same answer, y. What's the derivative of the cosine? Look, of stuff, it's complicated. It's not just x's in there. So derivative of sine of stuff is cosine of stuff times the derivative of the stuff inside. Derivative of pi x is pi with respect to x, and derivative of negative y is negative dy dx. Alrighty, now. Let's think about this. I did something weird here. Hang on. I'm looking at my notes. I tried this beforehand, and I think I did something weird. Oh, I see what I did. Okay, so in other words, you could get dy dx alone if you want, but why? We're dealing with the point where x is 1 and y is 0, right? So all we really care about is what dy dx is if we plug that in. Ah, yes. So it's going to be really complicated algebra to get dy dx alone. You don't have to get dy as an explicit function of x or even an implicit function of x and y. Dy dx alone, you don't have to. Look, try this. So we're looking at the point 1 comma 0. So if we plug in 1 for x and 0 for y, we get dy dx is 2 cosine of pi, because pi times 1 is pi minus 0 for y, right? Times pi minus dy dx. I don't know if that simplified a heck of a lot, but I guess that helps. All right, so what if we figure out what the cosine of pi is? Well, the cosine of pi is negative 2, right? The cosine of 180 degrees is negative 1. So I get a negative 2 there. So this really simplifies to dy dx is negative 2 times pi minus dy dx. Okay, good. Or dy dx, let's distribute to negative 2, is negative negative 2 pi. Yeah, negative 2 pi minus plus 2 cosine 2 dy dx, right? Okay, so we continue on the next side, on the next page. All I have to do is subtract. Well, how about I can probably sneak it in here. If I subtract 2 dy dx from the other side dy dx, you're going to get negative 1 dy dx is equal to negative 2 pi. So guess what? Dy dx is 2 pi. Okay, we've got the slope of the tangent line at that point along that curve, whatever that curve it looks like. Well, actually, no, we don't know what that looks like. Okay, so now let's write the tangent line. Okay, so the slope is 2 pi, right? Okay, here we go. So we're just going to do the tangent line is y minus y1 equals m times x minus x1. Now y1 is 0. Remember, we plugged in 0 for y. M is 2 pi, and x1 is 1. We plugged in 1, right? Okay, that's it, unless you want to simplify a little bit. But the normal is the same thing. Y minus y1 doesn't change. X minus x1 doesn't change. The slope changes. What's the negative reciprocal of this? So, because the normal line is simply perpendicular to the tangent line, at the same point. At x equals 1, y equals 0. So negative 1 over 2 pi. Remember, perpendicular lines, their slopes are related as negative reciprocals of each other. Now, I guess you could simplify a little bit here. The tangent line is y equals 2 pi x minus 2 pi. And the normal is y equals negative 1 over 2 pi x plus 1 over 2 pi, if you want to write it in mx plus b form, but you don't have to. You could leave it like that. That's an answer. What's nice about mx plus b form is, like here, this says start at b equals to negative 2 pi on the y-axis, like negative 6.28ish, right? And then the slope is go up 2 pi over 1, go up 2 pi over 1, right? That's easy to graph. But this is just as easy to graph. It says start at the point 1 comma 0 and then count the slope from there up 2 pi down over 1, up 2 pi over 1. But start at the point 1, x is 1 and y is 0. So you could leave it in slope-intercept form or slope-intercept form. Wait, hang on. You could leave it in point-slope form this way. This is point-slope form because you have a point and a slope. Any point doesn't have to be the y-intercept. Or you could put it in slope-intercept form, mx plus b form, either way. So this is an answer too. This is fine. You don't have to go into y equals mx plus b form unless you want to make it easier to graph or put it in your calculator or something. So I'm going to say, you know what? Let's simplify this. I'm going to say, in this case, I'm going to say just leave this out of here. Unless you're graphing on your calculator, leave this out of here. If you get y alone, then it's easy to graph on your calculator. But this is an answer. You're done. So notice the two equations are the same because y minus y1 and x minus x1 are the same thing. It's just the slope, the m, that's changing. So instead of 2 pi over 1, it's negative 1 over 2 pi for the normal. Alrighty, and I think we're done. Good. That was 25. And let's see, there's another one. There's a 35. Okay. And 35 is not implicit, but it is chain rule. Okay. Implicit is an application of the chain rule, but It's not always about implicit functions, is it? So page 167. Number 35. I think that's all the multiples of 5 I got on that page. Okay, so 35 says, find dy dx and dy dx second derivative and first derivative. Okay, so if y is 2x plus 5 to the negative 1/2, in other words, 1 over rad 2x plus 5, if they gave it to you that in that form, you would just rewrite it this way. If they said, what's the derivative of 1 over rad 2x plus 5, you could do quotient rule or write it this way and then do power rule and chain rule and stuff. Okay, so how do you take the derivative of stuff to the negative 1/2? Think of it as a power rule. You get negative 1/2 stuff. Now take 1 away from negative 1/2 to get negative 3/2 times the derivative of this stuff with respect to x. That's going to be derivative of 2x is 2, derivative of 5 is 0. That's it. So you could say, how about the 2's cancel? You can say negative quantity 2x plus 5 to the negative 3/2. And you can write this in radical form if you want, but you don't have to. And so that's dy dx, sorry. So what's the second derivative? Well, differentiate this the same way. So bring down the negative 3/2 times the negative 1 in front, so there's positive 3/2 stuff to the, what's 1 less than negative 3/2? Well, negative 3/2 minus 1 is negative 3/2 minus 2/2 is negative 5/2. Times the derivative inside is 2 again. So the 2's cancel, you get positive 3 stuff to the negative 5/2. And you don't have to write in radical form. That's it. Okay, so I think that's good for today, guys. Good luck with your homework. You got 10, 20, 30 on page 167. That's due on Monday. That's the first homework check from